गुड मॉर्निंग स्टूडेंट्स। आपको सारे नोट्स वीडियोस बुक्स वगैरह मिल गई होंगी। बेसिकली थोड़ा सा मेरे बारे में बताता हूँ। मेरा नाम पुनीत है। एमबीए का क्लासेस लेता हूँ। 2006 से पढ़ा रहा हूँ। 20 इयर्स का मेरे को एक्सपीरियंस है। वीजू, पूर्णिमा, जेईसीआरसी, आर्या, आईएलएम, आईआरएम, आईपीएस बिजनेस स्कूल सब में मैं जा रहा हूँ और एज अ गेस्ट फैकल्टी पढ़ा रहा हूँ। और इवनिंग में मेरा क्लासेस चलता है, ऑनलाइन ऑफलाइन रिकॉर्डेड, तीनों मोड पे क्लासेस चलता है। उसके अलावा एक टॉप कॉलेज है एमबीए का, आईएम अहमदाबाद, वहां मैं बच्चों को हर साल लेके जाता हूँ। मुंबई में एआई यूनिवर्सल, यहाँ पे गेस्ट पढ़ा रहा हूँ मैं। जेईसीआरसी में पढ़ा रहा हूँ, आर्या कॉलेज में पढ़ा रहा हूँ। इन कॉलेजेस में मैं पढ़ा रहा हूँ। देखिए, राइटर भी हूँ। 2008 से मैंने बुक्स वगैरह लिखना स्टार्ट कर दिया था। यूट्यूब पे सारे वीडियोस मिल जाएंगे, रिकॉर्डेड लाइव लेक्चर सब कुछ मिल जाएंगे। बस एक छोटा सा इंपॉर्टेंट डिस्कशन आप लोगों से करना था। एमबीए आप कहीं से भी करें, थोड़ा सा मेरे से आप डिस्कस करके अगर आप एमबीए ज्वाइन करते हैं तो आप थोड़ा सेफर मोड में रहेंगे। उसका रीजन बताता हूँ क्यों। क्योंकि मेरे को जो एक्सपीरियंस है ना 20 इयर्स का, एमबीए में प्लेसमेंट होगा कि नहीं होगा, कॉलेजेस कैसे पढ़ाते हैं, क्या उनका प्लेसमेंट स्ट्रक्चर है, क्या इंटरनल एक्सटर्नल इन्फॉर्मेशन है, मेन चीज अंदर क्या चल रहा है उनके। क्योंकि मैं तो रेगुलर कॉलेजेस में जा रहा हूँ तो मेरे को पता है कौन से कॉलेज में क्या चल रहा है। तो आप मेरे से थोड़ा सा एडवाइस लेके अगर आप एडमिशन लेते हैं तो थोड़ा सा सेफर जोन में रहेंगे। बाकी आपके डिस्टेंस के ऑनलाइन के एडमिशन, मणिपाल हो गया, एमएटी हो गया, ज्ञान विहार हो गया, तो यहाँ भी आपको अवेलेबल हो जाएंगे। तो आप अगर एडमिशन लेते हैं तो प्लीज मेरे से कंसल्ट करना। हो सकता है कि मैं आपको एक बेस्ट कॉलेज बता पाऊं और एक सेफर जोन में लेके जा पाऊं। क्योंकि एडमिशन लेने के बाद बच्चों को लगता है कि यार गलत जगह चले गए। ओके, बेस्ट ऑफ लक। मेरा नंबर आपके पास है। साथ के साथ अगर आपको कोई और क्वेरी चाहिए तो मेरे को व्हाट्सअप करें या कॉल कर सकते हैं। ओके, बेस्ट ऑफ लक।
Imagine for a second that you're walking into your office. Or maybe you're just setting up in your home office with that second cup of coffee. You sit down, you crack your knuckles, open up your laptop, and
Nothing happens.
literally nothing. No email loads, you can't access the shared drive. You try to message your colleague to ask what's going on, but the app just spins. You can't even send a document to the printer down the hall. Suddenly that really expensive machine is just a very sleek paperweight.
Yeah, it's a terrifying thought, honestly.
Yeah.
But it perfectly illustrates this weird paradox we live in. We tend to think about our work entirely in terms of the nodes,
A nose.
right? The people, the laptops, the specific applications we click on. But there is this entirely invisible nervous system underneath all of that, which actually makes the work possible.
Exactly. And usually we treat it like oxygen, right? We don't notice it at all until it's gone. But for today's deep dive, we are forcing ourselves to notice it. We're getting into the backbone of how modern organizations actually function.
Which means we're talking about network infrastructure in management information systems.
Yeah.
Or MIS.
Right. And before anyone reaches for the skip button because they think we're just going to read a textbook about Ethernet cables for 20 minutes, stick around, because this is actually a massive strategy conversation.
Oh, absolutely. It's the study of how we move data from point A to point B, and more importantly, why the actual way we move that data determines whether a business is agile or whether it's, well, a dinosaur.
Because if you can't move information, you just can't make decisions. So looking at our research for today, we're exploring MIS core concepts. We'll look at the hardware, the software, the rules of the road, and we have a huge real-world example to look at later called the NKN, which is just a beast of a network.
It really is. The NKN is essentially the final boss of network case studies.
I love that, the final boss. But our mission today is really to demystify this black box. We want to move you beyond just asking, is the Wi-Fi working? And understand the specific architecture that makes collaboration happen. So let's unpack the definition first. When we say network in the context of MIS, we aren't just talking about the internet, are we?
No, definitely not. At its most fundamental level, a network is an interconnected infrastructure enabling the transmission and exchange of data within or between organizations. But I think the key word there is infrastructure.
Meaning it's built for a purpose.
Exactly. It's not just a wire plugged into a wall. It's a system designed specifically to bridge the gap between raw data and actual decision-making.
And the scope of what that entails has changed so much. I feel like 10 or 15 years ago, we talked about LANs, local area networks, as these little closed loops inside a single office building.
Right, that was the era of the strict internet. You had your LAN, which covered your office floor, and maybe you had a WAN, a wide area network that connected your New York office to your London office.
But today, the edges are just incredibly blurry.
Because of the cloud. Now, the network encompasses extranets, the internet, cloud resources, third-party vendors. But even though it feels like this invisible global fabric, we have to remember it is still made of physical stuff.
Right, the cloud is literally just someone else's computer. So let's break down the two pillars of this infrastructure. We have hardware and software. Let's start with the stuff you can physically kick if it stops working. The hardware.
The tangible equipment. Our materials list the classics here: routers, switches, servers, computers, storage devices. But I think it's more important to distinguish what they actually do strategically.
Okay, well, let's take the router. I think most people visualize that blinking plastic box sitting in their hallway. But in a business context, it's more like air traffic control, right?
That's a really good analogy, yeah. A router connects different networks together. It decides the absolute best path for your data packet to take to get to its destination. It looks at the map and says, traffic is bad on Route A. Let's send this batch of emails via Route B.
Whereas a switch is more local.
Right. A switch creates a network. It connects devices within a single building or a campus. It's like the internal mailroom sorting letters between departments, while the router is the main post office sending letters to other cities.
That makes sense. And then we have the servers, which are the heavy lifters.
Exactly.
And these aren't just faster desktop computers, right? Like, they serve a completely different architectural purpose.
Yeah, they are high-performance machines dedicated entirely to managing network resources. They host the applications, they store the massive centralized databases. In this kind of architecture, the server is the library where all the knowledge lives.
But here's the thing. You could have a room full of the most expensive routers and servers money can buy. But if they don't know how to talk to each other, you basically just have a very warm, very noisy room.
Which brings us perfectly to the second pillar, the software. This is the invisible manager of the whole operation. You have network operating systems, or NS.
Like Windows, but for the network.
Precisely. Just like your laptop needs Mac OS or Windows to function, the network hardware needs an OS to manage users, security, and the actual flow of data.
But the software alone isn't enough either. This is where we get into the concept of protocols. And I want to pause here for a minute because this is often where people start to glaze over, but it's actually the most critical part of the entire puzzle.
It really is. Think about it this way. In a modern office, you have a completely heterogeneous environment.
Meaning a mix of everything.
Right. You've got iPhones, Androids, Windows PCs, Linux servers, smart thermostats, and maybe some legacy mainframe from 1998 that the accounting team refuses to let go of.
It's a total Tower of Babel situation. None of these machines naturally speak the same language.
Exactly. Without a standard, you just have chaos. And that's where communication protocols come in. A protocol is essentially a diplomatic treaty. It's a strict set of agreed-upon rules and conventions that govern exactly how data is formatted and transmitted.
Like saying, we all agree the address goes on the top left, the stamp goes on the top right, and the message goes in the middle.
Exactly that. And if you violate the treaty, if your device doesn't follow the protocol, the other device just ignores you. It entirely drops the packet. It's what ensures compatibility across billions of devices, the most famous one obviously being TCP/IP.
Which basically runs the entire internet.
Right. Transmission Control Protocol and Internet Protocol. It breaks your data into tiny packets, addresses them, and ensures they arrive in the exact right order. It's the handshake that allows a smartphone in Tokyo to seamlessly load a website that's hosted on a server in Texas.
Incredible. So we have the components, the hardware, and we have the language, the protocols. But there's another layer in the research that I found really visually interesting: network topologies.
Ah, yes, the actual map of the network.
Yeah, and at first glance, reading through this feels a bit like geometry class. The sources list types like star, bus, ring, and mesh. But this isn't just about drawing pretty diagrams for an IT manual, is it?
No, absolutely not.
Yeah.
Topology is pure strategy. The physical and logical arrangement of your nodes determines two crucial things for a business: performance and resilience.
Okay, let's look at the star topology, because this is the most common one we see in homes or small offices.
Think of a bicycle wheel. You have a central hub, usually a switch or a main server, and every single device connects directly to that hub via its own cable, the spokes.
It's super efficient, it's really easy to set up, but there's a catch.
A huge catch. There is a single point of failure. If that central hub burns out or gets unplugged, every single spoke on the wheel goes dead. The whole network completely collapses.
Which is terrifying for a business. Contrast that with a mesh topology.
Right. A mesh is the survivalist's choice. In a full mesh network, every single device is connected to every other device. It literally looks like a complex web.
That sounds incredibly expensive to wire up.
Oh, it is. It's very expensive, and it's highly complex to configure. But think about the resilience you buy with that. If one line gets cut by a backhoe outside, The data just instantly reroutes through a neighboring node. If a router explodes, the traffic just flows around it like water.
So for a business leader, choosing a topology is actually a risk management calculation. Do we pay a premium for the redundancy of a mesh to ensure we never go offline? Or do we save money with a star topology and just pray the central hub doesn't break?
Exactly. The topology directly influences the scalability and the uptime of your entire organization.
Okay, so we've built the beast. We've got the hardware, the protocols, the topology, but let's zoom out to the executive level. Why do we do this? Why do companies spend millions of dollars on this infrastructure? It can't just be so we can send memes on Slack.
No, though that is a very popular use case. The why is what justifies the massive investment, and it transitions us from technical components to real functional benefits. The primary driver is really about breaking down organizational silos.
Explain that a bit more.
Well, before we had robust networks, data was physically trapped. If the sales team had a spreadsheet of new leads, it lived on a specific hard drive in the sales department. If marketing needed to see it, someone had to put it on a floppy disk or a USB drive and physically walk it over.
The classic sneaker knit.
Exactly. And that creates massive latency. You can't make decisions based on real-time reality if it takes a day just to get the data.
Right.
So the first major benefit of a network is information access through centralized databases.
Creating a single source of truth.
Correct. The network allows users to access applications and data repositories from remote locations instantly.
Yeah.
This means the inventory number the warehouse manager sees on her screen is the exact same number the CEO sees in the boardroom.
And that ties directly into agility. You just can't make fast business decisions if your data is 3 days old.
Precisely. And that leads right into the second big benefit, which is data sharing and collaboration.
Which is really the difference between working on a file and working with a team.
Right. Think about the old shift from emailing a Word document back and forth, getting totally confused about version 2 versus version 2 final, to working in a cloud environment where 5 people are editing the exact same document simultaneously in real time. The network creates a collaborative environment that drastically boosts productivity.
It effectively creates a virtual workspace that sits right on top of the physical one.
And there's a cold, hard economic angle to all this, too. Resource sharing.
Yeah, the text mentions sharing peripherals.
Right, things like printers, scanners, storage devices. It sounds mundane, but scale it up.
Mm-hmm.
Imagine if every single employee in a 5,000-person company needed their own high-end laser printer and their own massive backup server at their desk.
The capital expenditure, the CapEx, would be astronomical.
Exactly. Networks allow us to optimize resource utilization. You buy one amazing printer, put it on the network, everyone shares it. You buy one massive storage array in a server room, and everyone saves their files to it. It reduces operational costs significantly.
And of course, we have to mention communication channels.
Oh, we can't forget that.
Yeah.
Email, instant messaging, video conferencing, voice over IP. The network has entirely swallowed the traditional telephone system. These aren't separate things anymore. A phone call is just data packets riding on the exact same infrastructure we just described.
So we have built this amazing, high-speed, collaborative, cost-saving system. We've connected everyone to everyone. But I feel like there is a massive however looming over this conversation.
There is. Because by connecting everything and everyone, you have effectively created a massive, highly efficient playground for bad actors.
Right. In the old days, to steal a file, you had to physically break into the building and open a filing cabinet. Now someone can try to steal it from a basement on the other side of the planet.
Exactly. Connectivity brings vulnerability. And that's why the next major section of our source material focuses heavily on safety and continuity. We have to talk about the shield.
The security mechanisms. The sources list a few non-negotiables here. Firewalls, encryption, access control, and intrusion detection systems.
Let's break them down. The firewall is your perimeter defense. It's the security guard at the front gate checking IDs. It monitors incoming and outgoing traffic and stops unauthorized access from the public internet into your private network.
But once someone is inside the building, you still need rules. That's access control.
Right. Just because you have a badge to get into the lobby doesn't mean you have the keys to the vault. Access control ensures that only specific authenticated people can see specific, sensitive data.
And what if someone does manage to intercept the data while it's moving across the network? That's where encryption comes in.
Encryption is absolutely critical. It's like writing your letters in a complex code that only the intended recipient has the mathematical key to decipher. Even if a hacker successfully intercepts the data packet, if it's properly encrypted, it just looks like random gibberish to them.
I really like the concept of the intrusion detection system in our notes. It feels much more proactive than the others.
It is. It's not just a lock on a door. It's a motion sensor. It actively monitors the network for suspicious patterns. Like if someone is trying to guess a password 500 times a second, the IDS flags it and alerts the network administrators immediately.
But the threat isn't just hackers, right? We're talking about physical infrastructure. Hardware fails, power grids go down, floods happen.
Which brings us to the concept of the safety net, disaster recovery, and backup.
The text specifically emphasizes network-based backup.
Yes, because the network connects everything. It allows us to back up vital data automatically and continuously to offsite locations. If your primary office server room catches fire, the data is already safe in a secondary cloud server 3 states away.
Ensuring continuity of operations.
That's the fancy business term for ensuring we don't have to bankrupt the company just because a hard drive crashed.
Yeah.
Whether it's a ransomware attack or a hurricane, the network infrastructure is what allows the organization to recover its data and keep moving forward.
Okay, so we've covered the theory. We know the hardware, the topology, the massive benefits, and the severe risks. But I really want to ground this in reality. The source material provided a highly specific, massive example that I think illustrates the absolute pinnacle of what a network can be.
The NKN.
Yes, the National Knowledge Network. This is a major initiative out of India.
It's a perfect case study for this topic because it shows what happens when you build a network specifically optimized for intelligence, rather than just commerce or social media.
So what exactly is it?
It is an advanced high-speed network infrastructure designed specifically to connect academic and research institutions across the entire country. We are talking about linking universities, nuclear research centers, agricultural labs, and national libraries into one massive, cohesive grid.
And when the text says high speed, the specs here are just wild. It mentions connectivity scaling up to 100 gigabits per second.
Which is blistering speed. But the real question is, why do you need that much bandwidth?
Yeah.
You certainly aren't using a 100 gigabit line to stream movies.
Right. The sources outline some highly specific use cases. One that really stood out to me was collaborative research.
This is the backbone aspect of the NKN. Modern science, things like genomic sequencing, global climate modeling, particle physics, these fields generate petabytes of raw data. You physically cannot email those files.
No, you'd need a fleet of trucks full of hard drives just to share a single experiment.
Exactly. But with the NKN's infrastructure, a researcher in one city can access and process an enormous data set sitting on a server in another city, as if that server were sitting right next to their desk. It completely removes the friction of distance for scientific collaboration.
And it's not just sharing data files. There is this fascinating detail about sharing big iron.
Yes, I love that term. Big iron refers to the super expensive, incredibly heavy-duty scientific machinery. Things like supercomputers, large-scale electron microscopes, wind tunnels.
These are assets that a small or regional university definitely cannot afford to buy on their own.
Precisely. And this is where the network becomes a powerful democratizing force. The NKN allows researchers to share these rare scientific instruments in computing facilities. If you are plugged into the network, your small lab can run a complex physics simulation on a supercomputer located hundreds of miles away at a partner institution.
That is incredibly cool. It leverages shared infrastructure to completely level the playing field for researchers.
It creates a seamless scientific ecosystem, and it also extends deeply into e-learning. The NKN facilitates highly interactive virtual classrooms and the high-speed delivery of complex multimedia courses.
And access to knowledge itself. The text mentions providing seamless access to massive digital libraries and international scientific databases.
It binds the entire academic community together. Whether you are at a premier institute in a major metropolis or a smaller college in a remote rural area, if you have that connection, you have immediate access to the global repository of human knowledge.
It really drives home the point that the network is not just a utility, it's an enabler. It enables feats of collaboration that physically would not be possible otherwise.
That is the ultimate takeaway here. The NKN promotes profound data sharing and collaboration through highly secure channels. It proves that a network is a strategic asset that determines exactly how fast a nation or a company can learn and innovate.
So bringing it all back home, we started this deep dive looking at the invisible nervous system of an organization.
We did. We defined the network not simply as getting on the internet, but as a complex, deliberate system of hardware like switches and routers, governed by software protocols.
We looked at the map, the topologies, and realized that whether you choose to build a star or a mesh, directly determines whether your business is fragile or resilient?
We discussed the vital functional roles, enabling real-time collaboration, providing that single source of truth for decision-making, and saving real capital through resource sharing.
And we looked at the inevitable risks, the absolute need for shields like firewalls and safety nets like network-based disaster recovery.
Finally, we saw all of that theory realized at scale in the National Knowledge Network. Tangible proof that a robust infrastructure can revolutionize how an entire community handles research and education.
It's strange, once you really start looking for the network, you see it everywhere. Every time you tap to pay with your phone, every time a package arrives exactly on time, every time a hospital instantly pulls up a patient record.
It is the silent partner in almost every modern human interaction.
So, here is a thought to leave you with today. We talked about topology earlier, about how the physical arrangement of nodes determines the strength and survival of the network.
Right, the star versus the mesh.
If your personal knowledge, your career resilience, and your ability to innovate depend on your own network of information, how is your topology arranged?
That is a very provocative question.
Is your personal network a star where everything depends on one central hub? Maybe one boss, one specific software skill, or one single source of news. A hub that, if it fails or becomes obsolete, leaves you completely disconnected.
Or are you building a mesh?
Exactly. Are you deliberately building a resilient, interconnected web of diverse sources, mentors, and adaptable skills that can easily reroute and survive a major disruption?
Resilience isn't just for routers and servers. It is definitely worth auditing your own connections.
Definitely. Just something to mull over the next time you're staring at a screen waiting for a page to load. Thanks for diving in with us today.
Until next time.